Hello, and welcome to our simulation, our lab simulation, which is a magnetic field around the wire. Once you click on the link, scroll down, and you will see a current carrying wire. This represents our wire where electricity is flowing through it. And we see that there is a down arrow. The down arrow represents the current flowing through the wire, whereas these yellow little dots here represent the electrons flowing through the wire. We have a positive end of our battery here and a negative end of our battery. Even though we don't see the battery, we use a positive and negative to show you that it is connected to the battery itself. And it also shows you that the electrons are flowing from the negative end of the battery terminal to the positive end of the battery terminal. So this tells you that electricity is flowing through our wire. So if we look at our down arrow, which is the direction of the current in the wire, which is the opposite of the electron flow, we see that we have a compass needle here. Remember, the red end of our compass needle represents the north end of our compass, and it will trace the magnetic field around this wire. Remember last time we traced the magnetic field of a bar magnet. This time we're tracing the magnetic field of a current carrying wire. So it shows, since I reverse the current, no matter which direction I reverse it, the compass needle is going to react. So this shows me that a current can produce a magnetic field, not just a bar magnet, that any type of electricity flow in a current carrying wire will produce a magnetic field. And this shows in our compass here. So if I move my compass and trace the path of the magnetic field around the current carrying wire, I see that my compass needle moves in a circular pattern and that it is moving clockwise, which means it's moving to the right around the current carrying wire as the current is flowing down. However, if I reverse the current and now the current is flowing up, my electrons are flowing down, I see that my compass needle has changed. It is now going in counterclockwise motion, which is to the left. So now it's still moving in a circular pattern, but instead of going clockwise, we are now moving in the opposite direction, which is counterclockwise. So if I go to my next tab here, and if you go back to the next slide, which shows these symbols right here, I'm going to move my arrow in the direction of the magnetic field going around a current carrying wire. So we saw when the current is going down that it was moving to the right, which is counterclockwise. So I'm going to move my arrows to the right to show that it is a counterclockwise pattern. Actually, I moved that in the wrong spot, so I'm going to move this over here. Get these just right. There we go. Took me a second. Okay, so we saw here that when the current is going down, it is moving in a clockwise pattern. So I'll just move my arrows to represent the clockwise pattern. Now, when the current was going up, it moved in a counterclockwise pattern, which was to the left. So I'm going to adjust my arrows and keep moving them around until I have a counterclockwise pattern, which is showing that it's moving in a circle going towards the left. So this is my counterclockwise pattern of my magnetic field. So again, this shows clockwise pattern, counterclockwise pattern. So we see that the magnetic field around a current carrying wire is going to be circular.